Okay, so in this video, it's our second installment of the Intermediate Lesson Week 6 review problems. This first book's problem says Mr. T has 12 different math books he wants to put on a shelf. There are only room for 6 books. How many ways can he arrange 6 books on a shelf? Well, when you do this problem, this is actually a classic permutation problem. You've got 12 things to pick from, and you need to pick 6 of them, but it's a permutation and not a combination because your order, when you finally pick the books, the way you order the books matters. If I just said, how many ways can I pick 12 books to put on a shelf, then it would be 12 choose 6 or 12 combination 6. But this is a permutation, so the answer is just going to be 12 times 11 times 10 times 9 times 8 times 7, which when you multiply that out, you get 665,280 ways. So that's how many ways you can put those books on a shelf. 9 is different because you reach in a bag and you grab out the 3 marbles, but it doesn't matter where you grab them out. It doesn't matter the order they've been grabbed. And so this one's just going to be 11 choose 3 because you got 11 marbles, you're choosing 3 of them. So it's 11 times 10 times 9 over 3 times 2 times 1. And so when you go through and cancel these out, you can see that the 3's cancel, the 2's cancel to 5, and so you end up with 11 times 5 times 3, which equals 165. So there are 165 different combinations of marbles that Jake could pick. All right, this is our path problem, and if you remember, we had a very specific way to do this. Now, actually, this is a good way to explain this is to recognize that the path of shortest length is, if you count up these marks, is set 12. There are 12 possibilities. And so essentially what's happening on this problem is you're making 12 decisions, and those decisions are all going to be either you go up, or do you go down, or do you go to the right? And so I need to make 5 decisions to go down, and so the question is, where do I make those 5 decisions at? And it doesn't matter where, they can be anywhere on here. So for instance, this would be one example of a path that was taken, right? That path particular would be down, and then right, 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 down, down, right, down, right, 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 down. That's that path I just described. And so the real question is, how many different places can I choose the 5 downs? And so it's going to be 12 choose 5. And when you figure out 12 choose 5, it's just 12 times 11 times 10 times 9 times 8 over 5 times 4 times 3 times 2. And so the 5 and the 2 cancel out to 10, the 4 and the 3 cancel out to 12. So you got 11 times 9 times 8, which turns out to be 792. So there are 792 paths from A to B in this particular problem. 11 is a similar problem, except just worded differently. It says how many paths of shortest length are there from any 2 opposite corners. So it's saying how many paths are from here to here, or from here to here. It doesn't matter which one you do. Same problem, you think about how long the shortest path is. 1, 8, 9, 10, 11, 12, 13. It's going to be 13. You need to choose 4 of them going down, so 13 choose 4. And so that just equals 13 times 12 times 11 times 10 over 4 times 3 times 2 times 1. So the 12 cancels out, a 2 cancels with the 10 to make 5, so you end up with 13 times 11 times 5, which equals 715. So there's 715 ways to get from any corner. It doesn't matter which corners you went from, they'd all be the same. 12. All right, this one is that sticks and stones problems we did before. How many ordered triples of whole numbers solve the x plus y plus z equals 14? Well, because we said whole numbers, that means 0 is a possibility. Right? Remember, we think about this problem as put 14 slots, and then we're going to go through and pick of the gaps in between the slots. We need to pick 2 of them to give us 3 different numbers. Like for instance, if we pick this one and this one, that would give us 3, 3, and then 8. However, that doesn't work for this problem because you need whole numbers. This doesn't account for any zeros. So to make these all whole numbers, we just add 1 to each of these. And so we end up with adding, that means we add 3 to over here, so we actually have 17 slots, which means we have 16 places in between the slots. And so you can do 16 choose 2, which is 16 times 15 over 2 times 1, which gives you 8 times 15, which is 120. But again, the question is, how many blanks, how many ways can you separate those blanks? 13 is a similar problem. Mrs. Lewis has 18 pieces of candy, and she wants to give it to 5 students. Now it says each receive at least 1 piece, so we don't have this problem of 0, so we just put our 18 slots down, and then because there are 5 students, to separate it into 5 different groups, we need 4 slots. And so it just turns out to be 18 choose 4, which would be 18 times 17 times 16 times 15 over 4 times 3 times 2. When you cancel this out, that becomes a 3, the 4 cancels with that, and you get a 4 there. And so you end up with 12 times 17 times 15. And when you do 12 times 17 times 15, it's going to give you, oh, that's where we messed up. This actually should have been 17 choose 4 and not 18 choose 4, so we need to correct ourselves. It should be 17 choose 4 because there are 17 places in between. So 17 times 16 times 15 times 14 over 4 times 3 times 2. So that's going to give you 2, and then you're going to have a 5 here. And so it's just 17 times 14. And when you do 17 times 14, you get 238. And then you've got 2 times 5 is 10. So there are 2,380 ways that we can distribute those candies to the 5 different students. All right, last question. How many paths of shortest length are there from A to B? Well, to do this problem, you have to recognize that you have this choke point right here, where every path that starts at A has to go through that point. So how many paths are there if we call this C from A to C? Well, that would just be 8 choose 3. Well, 8 choose 3, if you went through and calculated it, hopefully you're getting good at calculating that, would give you 56. Then every one of those paths, so any path that goes from A to C is going to be connected with the path from C to B. Well, the number of paths from C to B just gives you, well, there are 13 is the length, and so it's going to be 13 choose 5. When you do 13 choose 5, you come up with 1287. So there are 56 paths that go from here to here. There are 1,287 that go from C to B. And so the total number is just to multiply 56 times 1287, and you end up with this nice number, 72,072. And that's how many paths there are from A to B.